Go.
Hello, today we're going to do a lab that's called Finding Q. Q is your energy loss to heat or friction. So what we'll be doing is 4 different types of experiments, and then based on these types of experiments, we're going to have a energy conversion from potential energy or kinetic energy or potential energy to potential energy, and we're going to see how much energy is lost to friction. So for our first experiment, we are on an inclined plane. As you can see, it's a ramp. And we're going to start with our car at the top of the ramp. The car is starting from rest at the top of the ramp, so the car has no kinetic energy. It hasn't moved, so it hasn't lost any energy to heat or to friction. So therefore, at the top, it just has gravitational potential energy. The car will then roll down the incline, losing height, losing gravitational potential energy, and at the bottom, it will be converted into kinetic energy. And then when we get our kinetic energy at the bottom, the height, we're going to learn in a minute, the height is 0 at this moment. So it's got no gravitational potential energy. So at the bottom, it just has kinetic energy and energy lost to heat or friction. And what we're going to solve for is how much energy is lost to heat or friction.
Okay, let's find the height.
Okay, so the top of the ramp is 26 centimeters above the lab table. And the bottom of the ramp is 3 centimeters above the lab table. So the car will be dropping 23 centimeters. 0.23 meters will be the vertical displacement of the car.
Okay, now we're going to get the mass of the car. So we're going to put it onto our balance. And once again, the balance is going to get us our mass in grams. Looks like 38 grams. And when we convert from grams into kilograms, that will be 0.038 kilograms. Okay, so we're all set. We have our mass, we have our height. Mr. Peterson is going to turn that on so that we can get our velocity in meters per second, and we're good to go. All right, you ready, Mr. Fracchia?
Yep.
Okie dokies. Okay, so at the bottom, the velocity is 1.57.
And that is in meters per second, 0.157 meters per second.
And for the lab, it asked us to do this 2 more times. So we're going to reset this, and we're going to do the same experiment 2 more times. So, we're good to go, Mr.
All ready?
All right, start over again. And once again, the numbers should come out to be about the same.
For our second trial, our number came out to exactly 1.57 meters per second again.
Okay, and then we're going to do 1 more time.
Go.
And for our last trial, we have 1.59. So we have 1.57, 1.57, and 1.59.
All right, now we can go solve for finding Q. Okay, we are on to experiment number 2 for our Finding Q lab. For this experiment, we're going to take a golf ball, and with the golf ball, we're going to release it from a 1 meter height. At this 1 meter height, we're going to hold it still, so therefore at the top, it has all potential energy. We're going to release the ball, it's going to move down. When at the bottom, it's going to have completely kinetic energy, and then with our collision, we're going to lose some of our energy to friction, and as a result, when the ball moves back up again, it will not reach that 1 meter height. So just to show you what's going to happen, if I release this, it doesn't go exactly up to that 1 meter height. So we lost some energy there. And the purpose of the lab, once again, is to solve for finding Q, to figure out how much energy that we lost.
Okay.
In addition, we also have to get the mass of our ball. So when we're done with our 3 collisions, we'll go over to the balance and we'll get the mass of the ball for this experiment as well.
Okay, let's get the height.
Important to note for this one also, we're comparing potential energy at the top to potential energy when it bounces. So we're comparing 2 potential energies here, which is different than experiment number 1, where we were comparing kinetic energy and potential energy. Okay, let's do this. Is that 1 meter?
You got to go lower. Yeah, there's
Okey-dokey.
good. Okay, that was trial 1. Trial 2, a little lower. Okay. Okay, and trial 3.
Good.
Yep. Okay, let's get the mass of the ball. Okay, 46.3 grams, so 0.0463 kilograms. And we're all set, right?
Yes.
Okay. Yeah.
Okay, we are on to experiment number 3. So experiment number 3, once again, we are still solving for our finding Q. In this case, we're going to take a pendulum. We're going to start with the pendulum at some height over here, so it'll have some gravitational potential energy. And then what we'll do is we'll swing it through our B-spot, which will tell us how fast we're moving. And then when it swings through the B-spot, which it should swing through correctly, we'll be able to get the velocity of the ball at the bottom. And therefore, we can compare the gravitational potential energy that it has at the top, the kinetic energy that it has at the bottom, and the energy that would be converted into Qs for our finding Q lab. So to start this off with, we are going to get the mass of our marble.
Okay, so we have 23.5 or 0.0235 kilograms.
And then I'm going to set up the height while Mr. Peterson straightens out the pendulum over here. So we're going to release it from a certain height. So the height that we're going to raise the marble up to, and I'm going to measure my height here from the B spot because that marble over there is not at a height of 0, it's at some set height. So we're going to take it to the same height. I'm going to raise my marble each time to 35 centimeters. So 35 centimeters will be the height that I'm going to raise it to each time. And 35 centimeters we should know is 0.35 meters. Okay, so let's see how this works out. It's a little tricky to line up, so hopefully, oopsie, sorry. We're going to line this up, and then Mr. Peterson will start our B-spy. All right. Good. So he's going to grab that velocity for us.
That velocity is 2.48 meters per second.
2.48 meters per second for trial 1.
Trial 2, the velocity is 2.57 meters per second.
Oh,
And we'll try again for trial 3. And the velocity for trial 3 is 2.58 meters per second.
okay.
So we now have our velocity at the bottom and our mass, so we can use that to solve for our kinetic energy at the bottom. We have our mass and our height at the top, so we can use that to solve for our gravitational potential energy at the top, and then we can figure out how much energy is lost to heat or friction, so we can find Q. Okay, we are on to experiment number 4 in our Finding Q lab. And what we're going to do is we're going to take our sphere and we're going to put our sphere on our half pipe, which is located over here. We're going to roll the ball down that half pipe, and we're going to figure out how much potential energy is lost to heat or friction based on the height that it goes to on the other side. So we're comparing the potential energy at this location to the potential energy at that second location, similar to what we did when we balanced the golf ball in experiment number 2. So first things we need to do is we're going to get the mass of our sphere.
Okay, so that's 7.2 grams or 0.0072 kilograms.
Okay, and then we're going to take our sphere over here, and Mr. Peterson and I are going to hold our rulers up here. Now, every time that I release this ball, I'm going to release it from 30 centimeters. So each time it will be at 30 centimeters, which is 0.3 meters. So each time I'm releasing the ball for all 3 trials, it will be at 0.3 meters. And then Mr. Peterson will measure how high the ball goes to when it reaches the other side. So trial number 1.
Okay.
Trial number 2, again releasing from 0.3 meters.
Yep.
And then trial number 3, releasing at 0.3 meters. And we're going to measure for each of those from the middle of the ball. So we're going to see where the middle of the ball reached on the rebound height. Okay, good luck.